Hi, Siva. Let's all look at page number 8 now. We all look at page number 8. So first, by the way, today, hi, Meikei. Today we will be doing a revision for your. By the way, if there's any of you who want to join the Mandarin class is later 4:30 to 6:30. If you want to join the Mandarin class, it's 4:30. Yeah. Okay. So this revision is mainly to help you in your first term exam. Normally first term exam is chapter 1 until chapter 3. I'm not going to do chapter 1 today because chapter 1 is mainly just telling you what's chemistry, what are the things that you have to do in the lab, where lab code lah, and then when things happen, how can you solve the problems? Okay, and also what can you, what are the jobs, okay, that you can choose next time if you study chemistry. So here in the mission number 8, we will start with chapter 3 first, which is calculation. In order to be good in the calculation of chemistry, you must always remember these 3 formulas to calculate number of mole. So if you want to ask me, hey, would they give you this formula in the exam? The answer is no. No formula will be given in the exam. So you have to memorize them all. So what are the formula that you have to remember? Mole equals to mass over molar mass. What is molar mass? Molar mass is the mass of the chemical substance. For example, CO2. If you want to find the molar mass of CO2, the question will give you the mass of each alphabet. For example, C is equals to 12. O is equals to 16. All you have to do is plus them up. Yes, correct. Molar mass is actually RAM, correct? Molar mass is actually RAM. We just plus them up together. 12 plus 16 times 2. Like that. Is that okay? Can this is molar mass. What is the unit for mass? Please write down. The unit for mass is gram. How about molar mass? Molar mass is gram per mole. Gram mole negative 1, gram per mole. I think I put it down here. Gram per mole. Okay, can For volume, it is volume divide molar volume. So it's not too hard. Mass, you divide it by molar mass. Volume, you divide it by molar volume. Volume has a unit of dm cubed. Molar volume is dm cubed per mole. Okay, just like that, just like that. For number, I think you have learned this in the school, right? Most of the school teacher has already started to do chapter 3. So in chapter 3, the teacher will definitely teach you how to calculate number of mole. The first formula they teach you will be this one, number of particles over the Avogadro's constant. Do you know what is Avogadro constant? The 6.02 times 10 to the power of 23. Okay, and then what do I want to mention here? Oh, the unit for particles. The common units for particles can be atom, molecule, or ion. So you must know all the units for what they want to calculate in mass, volume, and also particles. So now let's go through the question and see how can we solve calculation questions by using just these 3 formulas. We go to page number, sorry, wait, number, where's my 5A? Oh yeah, 25. Page 25. If it doesn't have the notes, doesn't have the book, you can just take your calculator and then we calculate together. You just need a blank paper because it's just calculation. So first, this question you see, it says the molecular formula given is CxH11 Cl3 NO3 PS. Okay. So if the relative molecular mass of this chlorpyrifos is 350.5, determine the value of X. So they want to find the value of X here. And they told you what? Relative molecular mass. That means the mass of this whole substance is equals to 350.5. So I will just write it out. CX H11Cl3 chlor equals to 350.5. Okay, this thing is a molecule. What is a molecule? Molecule means it is consists of more than one alphabet. You see, got a lot of alphabet together, combined together. So it's called molecule. It has a total mass of 350.5. They want to find the value of X. How can you find the value of X here? You sub in all the other numbers. So see, C is 12. 12 times X plus H times 11 plus Cl 35.5 times 3 plus N plus O3, so O times 3 plus P and S. This is, by the way, this page is a warm-up question. Okay, it's the warm-up question. That means they are easier compared to what we have to do later. So it's equals to our 350.5. Can you please do this calculation? Press your calculator and then tell me X is equals to how much? Isabel, very good. Isabel, very good. The other students? Monisha, very good. But why can't I change my name? I'm wait, I change your name for you. Okay. I just put Sinman lah then. Sinman. Okay. CSY, very good. Sinling, very good. The answer is 9. Okay. Motion, also very good. The answer is 9. Well, thanks for the answer. Very good. Okay. Next question. Oh, by the way, they want you to rewrite the formula. I will just skip this one. Basically, you just have to rewrite the whole thing. I put it in the 9. Okay. Can anyone cannot get this answer? Ethan, can you get the answer, Ethan? Where's my Ethan? Oh, yeah. Ethan, answer or not? Can okay, correct. So calculate the percentage of water from crystallization in CuSO4.5H2O. Percentage. How to calculate percentage? It is the same as your maths. Let's say I have a pencil box that comes with 3 red pens and 7 of them are blue pens. So what is the percentage of red pen? If my pencil box has 10 pens, and yeah, the percentage of the red pen will be 30%. How to get 30%? 3 divided by the total, right? 3 plus 7 times 100. So now we got to do the same thing, but water. Water is H2O. Yeah, how many H2O? 5 of them. 5 H2O over, divide the whole thing, CuSO4 plus 5 H2O. Basically, the dot is just plus. And then times 100. What do we do next? Sub in the mass. In chemistry, it's like that. Always sub in a number for different alphabet. So 5 times H2O divided by CuSO4 plus 5 H2O times 100. To get, teacher, which page? Hi, Ashton. We are in page 25. Oh, Ashton is here. Wow, okay, we are in page 25. So what's the answer? Or CSY, CSY, can I know your name? At least like your so that I don't have to call you CSY like that. Hi, Zishan, hello. I rename. Okay. Monisha, okay, correct. Monisha, very good. Anyone else? Sawi, okay. I help you to rename. What's the answer? 45 is not 45, not 45. It is not 45. Ethan, can I have the answer, please, Ethan? Jacinta, very good. %. Wait, too late already. Okay, 36%. Just press your calculator. Anyone can't get this answer? Can This question, this page is just warm up. Later we'll be doing harder question. Now we haven't used the formula yet. Later we'll be using the formula. Okay, next. Relative formula mass. Let me know if I'm going too fast. Relative formula mass of X3PO42 is 259. Determine the relative atomic mass of X. So same thing, you have to find X again with the total equals to 259. So this time, sub in all the mass yourself for different alphabet. You sub everything in and find the X. And I wait for your answer. Once you got the final answer, please let me know. Sub in yourself and try to get the answer. Monisha, very good. Monisha, very good. Isabel, very good. Yes. Just try and press your calculator. If you can't get 23, let me know. If you need help, if you want me to write out the workings, you let me know. If you have any question, please ask. Okay, so far, okay. Everybody can get the answer? Okay, looks like everybody is good with this. Next, the following figure shows the structure. Done or not? Have you done? All done? Yes, okay. The following figure shows the structural formula of halotane gas, which is used as a general anesthesia during a medical operation. It is also called the sleeping gas. So calculate the number of mole of halotane in 39.5 grams of the compound. See, number of mole, 39.5 grams. So obviously, I see the word mole, and I also see mass. Gram is mass. So I will be using the formula mass over molar mass. They gave me 39.5 to sub into the mass. So I will just put it in. Divide by molar mass. Where can we find molar mass? Molar mass is actually the relative mass. We just have to plus them up together ourselves. So what is the formula? We count the alphabet ourselves. 1C, 2C. 1H, 3F, Br, 1Cl1. Okay, if you ask me, hey, how do I know which one have to come first and then which one later? You can always follow the sequence of the alphabet, okay, A to Z, or it actually doesn't matter. They don't care one. So as long as you are able to find the total mass, C2H plus F3 Br Cl. Ashton can, but this one, everything is non-metal. For this example, everything is non-metal. So we will be getting the answer 0. Yes, motion very good. 0.2 mole. Monisha, very good. Sinman, very good. All good, huh? Okay, next. 5B. The next page, huh? Page 26. So vitamin A is made out of carbon, hydrogen, and oxygen. Diagram below shows the molecular formula of vitamin A. Determine the mass of 1 mole of vitamin. Mass and mole. So that means I will be using mole equals to mass over molar mass. Same thing like just now. Mole is 1. They want me to find mass, so I leave it as unknown. Divide by molar mass. Yes, we have to count. You all help me to count H. You all count H, I count C. Then we can combine our answer together. How many H? $30. Okay, thank you. C20H30O. Okay. Then we sub in the mass. Molar mass is the mass of the substance, the mass of the chemical substance. So 12 times 20. This atomic mass will always be given. It will be given in exam. Plus H times 30 plus O. And our answer will be equals to 286. What is the unit? What is the unit for mass? Gram. Very good. Okay, Next, determine the mass of 0.0025 mole of vitamin A. So it's just a different mole. Just now was 1. Now they change it to 0.05, 0.025. So I just change the mole equals to mass over the total. Let me press my calculator. C20 plus 30 plus 16. 286. What am I doing? Just now times 1, so it's 286 equals to 7.15 gram. Yep. Easy, Okay, now question slowly getting harder. It's getting harder now. Determine the number of molecules in 20.02 gram of vitamin A. You see, without understanding the question, we can just apply the formula. Mole equals to number of particles over the Avogadro's constant. Because they say number, so I use the mole for number to calculate it. Vitamin A, 20.02 gram. This is mass. So mass over molar mass. And then from the number given, we start to sub it in. Subbed. 20.02 can be subbed into the mass. And then molar mass of the vitamin A is the 286, right? So divide 286. .07 mole. This question wants you to find number. And now I got the mole already. I sub it in. Number over Na. Na will also be given 6.02 times 10 to the power of 23. By the way, there's something I want to clarify here. Most of the students, they always think that mole is actually molecule. No, mole is mole. Molecule is molecule. What is mole? Mole is like a penjodoh bilangan. We have a pair, a dozen, and then a mole. Mole is the penjodoh bilangan being used in your chemistry. It represents the number. Okay, pair is 2, dozen is 12, and 1 mole is equals to 6.02 times 10 to the power of 23. Okay, so it represents a number, not molecule. So from here, you just have to move this to the other side. Becomes times. Ashton, very good. So we times it, and we will be getting 4.214 times 10 to the power of 22. Molecules. Mole and MOL same or not? MOLE and MOL is the same. MOL is the short form. It's the unit. For example, kilogram. Short form is kg. MOLE short form is MOL. So it's the same thing. There is no short form for molecule. Okay. Then next, less one letter only, because it's very short already, Okay, next. Calculate the mass of this amount of vitamin A. Same thing. They want me to find the mass. I use the formula mole equals to mass over molar mass. If they want me to find mass, I have to sub in a number for mole and also molar mass. So molar mass of vitamin A, 286. Do I have a mole here? Don't have, there's no number of mole. So what do I have to do? Find the number of mole. So from this value given, we sub it into this formula for number. This is a long number, a big number. So sub it into the formula of number. Can you all please help me to press the calculator and let me know the answer? What's the answer here? Thanks, Malcolm. Mushan, thank you. Very good. Monisha, very good. 1.25 times 10. If your answer is 1.25 times 10 to the power of 45, that means when you are pressing your calculator just now, you never put bracket. Must put bracket. Using 6.02 times 10 to the power of 23 or 6 times 10 to the power of 23. Follows the question. If the question is 6.02 times 10 to the power of 23, you have to use 6.02 times 10 to the power of 23. Okay. And the actual value is 6.02. Very seldom, sometimes a question will change to 6 times 10 to the power of 23. Sometimes that question will do that, but most of the time, it's always 6.02. Okay, you got the mole already. Sub it in. And the mass will be equals to 35. Oh, thank you. Very good. 35.75. Nice one. Okay. All good, all good. Let me see, Teacher, my calculator no put bracket also can get. That means you are using a different type of calculator. That means you are using the silver color one, is it? Okay. Next, page 27. Molecular formula, empirical formula. What is molecular formula? What is empirical formula? Guys, what is empirical formula? What is empirical formula? Simplify. Yes, simplest form. Yes, simplify. Yes, simplest ratio. Very good. Oh, very good. Yes, the simplify one. Okay, the simplest form. Very good. So the molecular formula of aspirin, you just count one by one. But here I will give you the formula. So to save some of the time, don't waste our time counting all this. C9H8O4. And the caffeine is C8H10N4O2. Simplify. Simplest form. If we simplify C9H8O4, it will be still the same thing. It cannot be simplified anymore. But this one can be simplified by dividing 2. So if we divide 2, we are going to get C4H5N2O. Relative molecular mass. Relative molecular mass. The mass of the molecule, that means you plus everything up together lah. Okay, plus everything up together. Where is the yeah, I forgot to give the what? The atomic mass. Never mind. I give you the value lah. I give you the figure. 180 and 194. Students, by the way, the reason why I give you all this question is because I want you to know that for relative molecular mass, you have to use the molecular formula, because sometimes when questions come out this way, students, they will just use this one and then find the mass. No, a simplified formula is like a fake formula. It doesn't represent anything. It is just empirical formula. Basically, it's just for fun. It's something created just to test you in the exam. Okay. So you have to use back the actual one. Calculate the number of molecules in 3.6 grams of aspirin. Can you all please try this question? You see, there is number, there is mass. So use the formula, the two formula to calculate, to find out the answer. Once you got the answer, let me know. Zishan, very good. Isabel, very good. What is Avogadro? Avogadro's constant. Okay, basically, you see, just now I have told you that mole is equals to 6.02 times 10 to the power of 33. Avogadro is the guy who found out that in 1 mole of substance, 1 mole is like maybe a pinch, a bit, okay? A bit of the substance will already have 6.02 times 10 to the power of 33 particles inside. So the guy found out this thing, so he named this thing, this number, by using his own name, Avogadro's constant. So Avogadro is 6.02. Yep. After you got the mole, use the number given to find mole. And then suck the mole in to get 1.204 times 10 to the power of 22 molecules. For those who can't get the answer, let me know. If you think I'm going too fast, let me know. Ethan, you okay or not? Is Ethan still here? Let me see. Still here. Ethan, Thursday I test you one. A cup of coffee, okay, nice, contains 0.005 mole of caffeine. Calculate the mass. Yeah, you see? After you have done a few questions, you'll realize very easy. You just, whatever number given, you just sub. As long as you are able to sub into the correct formula, you will get the answer. What's that? Oh, caffeine. Sorry, caffeine is 194. So 0.97. Thank you. Oh, just now I remember someone asked me this question. Where? Oh, just now asked me if the question gave us kilogram, do we have to turn it into gram? The answer is yes. You have to turn it into gram. Before you sub, that means before you sub, you have to change it to gram. You can't just put, let's say 3.6 kg. You can't just put 3.6. You have to write it as 3,600 gram. Okay. Next, let me see. Okay, can you this one? Since you are quite fast. Banana is rich in vitamin B6. This structure shows the formula of B6, vitamin B6. Name the element that made up a vitamin B6 molecule. Element is what I taught you all this week in the class. What is element? Element is what types of alphabet they use in making this substance. You see, the alphabet has H, we have H, has O, has carbon. So these three different alphabet is called element. Yes, so the name would be, the name for C is carbon. The name for hydrogen is, H is hydrogen. And the alphabet O is oxygen. And also, there's nitrogen. Okay. Nearly missed that out. Thanks, Malcolm. Okay, nitrogen. Carbon, hydrogen, oxygen, nitrogen. Very good. Molecular formula. Just count. Don't care the line. You don't care whether it's one line or double line. It doesn't matter at all. You will learn this in your chapter 5 later. Like, why is it one line, two line? But now it's not important. Just count the alphabet. It will be C8, H11, and O3. Next question, it asked, what is the molar mass of vitamin B6? Molar mass. Every time we see the word molar mass is in the formula, right? This one. And then for this molar mass, we always sub in the number of, we sub in the value, the mass for the whole thing, right? The mass of the chemical substance. So what we do here, what is the molar mass? We sub in the number. Where is the number? I forgot to put in. Okay, never mind. I give you now. C equals to 12, H equals to 1, O equals to 16, N equals to 14. So just press your calculator. C8, H11, and O3, 169. What is the unit? What is the unit for molar mass? Very good. Gram per mole. And then after this, number of molecule in 5.75 gram of vitamin B6. Wait, 16, yeah, lor. Just now I mentioned 169, right? How can I write 168? I'm sleepy already. 69. 0.034. Oh, okay, same. And then when the number is very long, we take 3 decimal, 0.034. Okay. And then this one, mass. All good. Meaning of empirical formula. Empirical formula, MM is 169. Yeah, 169. Then just now we calculate the total already. Molar mass, molar mass is 169. So all the molar mass we put 169. No? Okay, no? 0.034 mole. Yeah lah, this one lah. Let me write the definition of empirical formula first. Chemical formula which shows the simplest whole number ratio of atoms of each element in a compound. Definition has to be always be perfect. Normally, one word missing, they will just minus your mark. And you can't build your own sentence like explanation. And there are a lot of definition. But for me, I don't encourage students to go and memorize all the definition because usually in exam, they come out like 1 or 2 questions only. Unless your first term exam, your teacher want to kill you, they set the paper with a lot of definition. But in SPM, they got format one. They cannot keep on coming up definition one. They got like a rules one, like maximum maybe 2 or 3 only definition. They can't do more than that one. Empirical formula of aspartate. Empirical formula of aspartate. I think there's something wrong with the question. They want the empirical formula. Sorry, it's vitamin. Okay, we don't care about it. Okay, we just assume that everything is vitamin. Vitamin B6. The whole question is asking for vitamin B6. So the empirical formula for this vitamin B6 cannot be divided anymore. So it will be still C8H11NO3. Okay. Now, okay, next page. We want to find molecular formula from empirical formula. State the empirical formula of butane. Butane is C4H8, so empirical formula will be CH2. And then here is the important part. The molecular mass is 84. And the empirical formula is CH2. Molecule and empirical. Difference is molecular is the original formula. And this is the simplest form. When we simplify, we divide it with a number, right? Now, if we want to find back the molecular formula, we have to times a number. But we don't know what is the number. So what we have to do? Since I know that after simplify is CH2, and I want to multiply a number to get back the original one. What is the original formula? I don't know, but they gave me the mass 84. They gave me the mass 84. So, what do we do? See, chemistry is always something mass into the alphabet. CH2 times N equals to 84. 84 is after simplify. No. Molecular mass 84. That means before simplify is 84. Molecule is the actual one. 14 N equals to 84. N is equals to 6. Thanks, Monisha. What do you mean, Ashton? Only applies for molar mass. Which one? Yes, Malcolm, correct. Like what we did in the class last time, I think like 2 weeks ago, before the riot. After I know that N is equal to 6, I have to sub it in to get C6H12. You can also double check your answer by putting in the mass of C and H. C is 12, H is 1. You'll be getting back 84. So that means this formula and the mass is the same. Correct. Okay, so from empirical, you times a number, you'll be getting back the molecular formula. Okay, next question is something that you have to try it on your own. Butane. Butane is C4H10. Butane is C4H10. So what's the answer? About, do you mean 0.6 or 1.6? The question wants you to calculate the number of, yeah, spell correct, Yanling correct. Number of molecule of butane gas. You see, they gave you two substances, but they want to find butane. That means you can just ignore this one. To find the number of molecule, we apply this formula. They gave us mass, so I apply this formula. Sub the number in 1.75 divided by C 4H10 to get 0.03 mole. Am I right? Sub the mole in to get 1.806 times 10 to the power of 22 molecules. Ethan, how comes yours is 31? You press your calculator wrongly, is it? So we can just ignore the 150 cm. Yes, correct. We can just ignore it. Because the question wants you to find the butane gas. Okay, they say it's used to boil the water. Butane gas is actually your cooking gas. Okay, it's the cooking gas, yeah. So they say they use the cooking gas to boil the water. So this is like something to confuse you, but yeah. Next, yeah, finally, empirical formula, page 30. If I use 0.027 to count, let me see, 12 times 4 plus 10, this equals to 58. 1.75 divided 58. It should be 0.03. If you get 0.027, that means your number of mole is wrong. I think there's something wrong with your molar mass. Okay, this one. Empirical formula. Remember, in exam, you must draw the table out. You must draw the table out. The first box here would be filled with the word element. That means the type of alphabet C, H, N, and O. Then when you do the calculation, you find mass mole ratio. So how to find the mass of the substance when they give you percentage? Like for those who have attended the class, and yes, correct. When they give percentage, the total is actually 100 grams because percentage is 100% in total. When they give you percentage, that means the gram, the mass of the substance is also 100 grams. That means we can use the percentage straight away as mass. So 74.1, hydrogen is 7.4, nitrogen 8.64, and the rest is oxygen. So we got to minus it. To get 9.86. Then you see, you got the mass already, and the question wants you to find number of mole. What do you do? divide the molar mass of. What is the molar mass of C? 12. Press your calculator and get these three answers. Yes, Siva, correct for the first one. Monisha, very good. So everybody should be able to get the mole. Yes, 3 decimal places, correct. For the most accurate answer, we take 3 decimal places. Okay, after that, what we do next, we bring, because from all these numbers, it's very hard to know the actual ratio. If the mole is like 0.5 to 1, then the ratio is very simple. It's 1 to 2. Whole number ratio is 1 to 2. But this one, all decimal, wow, it's very hard. So what we do, we can actually bring all this number down and then we divide all the number by the smallest value. Jacinta, correct. The smallest among these 4 is the 616. So the whole number will be 10, 12, 1, 1. C10, H12, N1, O1. So C10, H12, NO. Why divide the smallest value? We divide the smallest value so we can make the smaller value to be equal to 1. Ratio, whole number ratio. When you turn it into 1, it's easier to compare. It is kind of the same like people who make it into 100, it times 100, something like that. But dividing 1, we can get 1 mole. So we can compare 1 to something like that. Okay, we got the empirical formula ready. Now, we have to find molecular formula. The actual formula. They say that the mass for the actual formula is 324. Please find the N and sub the N into the formula to get back the actual formula before simplifying. is equals to 2. Okay, thank you. C20H24 N2O2. I write NO bracket 2. Cannot write NO bracket 2. Must write like this. Find the number of atoms in 29 grams of quinine. Can you all please try to do this one? I think most of you will be getting the wrong answer. Try to give me your answer, then we see your answer same as mine or not. $1.79 no. $4.681. How come all yours answer different from mine one? Wait, I press again. Hey, wait. Oh, wait. Oh, okay, I know why already. Okay. Isabel's answer correct. Isabel correct. Malcolm correct. Malcolm, your power is wrong, Your power wrong already. Ashton, very good. Wow. Sorry. Ashton, wrong. I think because different people is using different number of mole, that's why all answer is different. First 20 gram divide by, you see the molar mass, the molecular mass, the total is 324, so it's divided by 324 to get 0.062 mole. Okay, then we want to find the number of atoms. Please be very careful when this question come up in the exam. When they want you to calculate number of molecule, don't worry, you just calculate it. You don't have to do any extra steps. But when you see find the number of atoms, please be very careful. How to be careful? 0.062, wait, let me finish my calculation first. Number equals over 6.02 times 10 to the power of 22. Okay, 33. To get 3.716 times 10 to the power of 22. The value that I calculated here, this quinine is actually a molecule. This is the amount of C20H24 N2O2. This is the amount of C20H24. But question want to find atom. That means we can actually convert this one set of alphabet. We separate them out into one by one. One single alphabet. So a bigger unit to smaller unit, kilogram to gram, km to m, we all do multiplication. So times. There are how many atoms in this molecule? 20 plus 24, 44 plus another 4 is 48. Right? So we times 48. To get 1.784 times 10 to the power of 24 atoms. Molecules not 3.7324. Wait, wait, yeah. When I press again, it is 7324. Sorry. 7324. 732. I think I pressed my calculator wrongly just now. Okay. $1.79. Okay. Ashton can, no problem. If your value is very close to this, is okay. For this kind of value that the number of mole has a lot of decimal one, that has a lot of decimal, when you press your calculator using a different way, some of them use the long number to straight away times 6.02, then you'll be getting a different number. It's actually okay. So for this kind of questions, your teacher will just look at like the 1.7. If you can get 1.7 times 10 to the power 24, then your answer will be correct. Okay, that means they accept the value which is like 1 decimal difference, like 2 decimal difference, like that. Otherwise, it will be very hard. Okay, just like that, times 48. But then, okay, nothing. When it is atoms, be careful. If they give you example, the example that they give you is not this one. Let's say I change it to Cu. Cu has how many atoms? Cu is how many atoms? 1, right? So if the substance itself is already an atom, please don't do these steps. It is atom already, it is one single atom already. You just straight away write atom. No need to write molecule and then times 1 like that. No need. Is that okay? Okay. I think everyone's okay with this. Then there's one last question I want to do. Page 32. 32. This is a slightly harder question. Page 32. So hydrocarbon X contains 85.7% of carbon according to mass. 5.6 grams of this hydrocarbon occupy a volume of 4.48 bm cubed. So there are a lot of information in this question. So students will get confused very easily. Find the empirical formula. If you have done exercise before, like practice before, you will sure know that the percentage is the one that is used to find the empirical formula. Like the question we did, what we use? Percentage as mass. So you have to know which value is for which calculation. Percentage of carbon is 85.7. Hydrogen will be the remaining 14.3. Okay. And then find the number of mole. $7.142. One to two, CH2. How did you get 14.3? 14.3. This one, percentage one, total is 100%. So that means you use 100 minus of 85.7, you get 14.3. Teacher, if without showing the calculation in H, does it wrong? You mean this one? If you doesn't write like this is wrong, you mean? The second, it's better to show calculation. It's better to show calculation, to show the workings. So the teacher knows that, oh, this student actually divide the molar mass. Otherwise, they will say, I don't know, maybe you just copy down the mass. Some teacher very pattern. If good teacher, they don't care. Right? So CH2. Molecular mass. What is the molecular mass? How to find molecular mass for this question? Usually, we need the molecular formula. Let's say C6H12O6. We need all this alphabet to suck the mass in, right? Like 12 times 6 plus 12 plus O times 6. But then this one is empirical formula. As I told you just now in this question, never use empirical formula for your molecular mass. Molecule is for molecule. But what we got here is only the empirical formula. We doesn't have molecular formula. How? So this is why they gave you these two values. They want you to understand that okay, this one okay, wait, okay, for those who don't know how to get the answer, after you got, okay, for empirical formula, after you got the mole, you bring all the mole down and divide by the smaller one. Which one smaller? 7.1, okay, 7.142. So we can make the smaller side to become 1. 1 to 2, like that. Okay. Or you can only round up. You can only round up when the number is like 1.9. A difference of 0.1, then you can round up. Only can round up when it is very close to whole number, 0.1 difference. If the value that you got here is like 1.5, can you round up to 2? Cannot. you have to times 2 to make it 3. Yeah? And then this one will be times 2 as well. Let's say 1.5. Only a difference of 0.1, you can round up. 5 cannot. Is it 28? Okay, see. The value they give us here is, okay, just now where I stopped was, they want you to understand that they are testing you the concept. Do you know that molecular mass is actually also molar mass? They want to test you on this thing. So if you know that molecular mass is also a molar mass, that means you will be able to get the molecular mass from this formula, mass over molar mass. They could give you mass or not? Yes, 5.6. So I sub it in. But I still need a number of mole in order to get the molar mass, right? Where do I find the mole? They gave me another value, 4.48. Mole equals to volume over molar volume. What's the molar volume? 22.4 dm3. STP, 22.4. You sub it in, 22.4. To get 0.2 mole. Sub the mole in. Yes, Malcolm, very good. 28. What is the unit, students? What's the unit? Teacher, how to know that is the molar volume? Oh, because in this chapter, wait, if you have learned calculation of this chapter, molar volume only got 2 types. One is STP, another is RTP. They will give you in the question, they will mention in the question one, STP or RTP. You straight away take the value and put it in. For molar volume, for this 6.02 times 10 to the power 23 will always be given. It's given one. What is the unit? Okay, for 28, unit for 28. Okay, so you see, I got most of the answer as gram per mole, but the answer here is no unit. No need unit. Why? Because for this question, they are not asking molar mass. They say, I know they are the same thing, but when they say relative molecular mass, relative got no unit. What is relative? Relative is like comparing. It is 28 times heavier. If your school teacher has explained, how many of you, your school teacher has already explained this one? 1/12 of carbon, and you can't understand. Your school teacher will mention this or not? 1/12 carbon, and then you can't understand. Me, okay. Yes. See, okay, what is 1/12 carbon or 1/12 carbon 12? Atom. Okay, see, relative mass. Now I explain to you what's relative mass. Relative means compared. How many times heavier? Imagine, okay. Okay, this is me. I want to know my own mass. Okay, I want to know my own mass. But there is nothing, imagine, okay, there's nothing can compare with my mass. There's only one substance can compare with my mass is this very fat guy called Jung Hao. Okay, but Jung Hao, when you look at him, he's a lot heavier than me. If I put him on this balance, immediately, it becomes imbalanced. Yeah. So that means I can never know my own mass. Jung Hao is the only guy in the world that he knows that his mass is 100. So he's the first guy who like, let's say, found out mass. He's the scientist. Okay, he knows mass. Okay, everything has mass. Then now, how do I find out my mass? I know that Jung Hao has a mass of 100. So what I do, I cut Jung Hao into 100 pieces. If I cut him into 100 pieces, that means it is 1 over 100. Jung Hao is 100 kg. I cut him into 100 pieces. That means one piece will be 1 kg, right? Then I start putting his 1 kg on the other side until this thing got balanced. So that means at first not balanced. My side is heavier. Okay. So I put the 1 kg, 1 kg, 1 kg. Hey, when I put 3, wow, it is balanced already. That means, oh, I found out that my mass is 3 kg. Or you can say that my mass is 3 times heavier than 1 over 100 pieces of Jung Hao. So that means this example is trying to tell you that carbon 12, it is called 12 because you can imagine carbon is 12 kg. I mean, imagine, not actually like 12 kg. Jung Hao is 12 kg. If you cut this thing into 12 pieces, 1 over 12, it actually means 1 kg. Okay, so that's the meaning of relative. That means in order to make this substance balance, what is this? X. I need (28) of them. To make this thing balance. So the relative mass will be 28. You see. Then Jason will say, then what is the point? Why they want to use carbon there? I use anything also can. You see, just now you say Jung Hao, I can also use Jung Hao. I can use water also. Water, I can use anything. So that's why there is a reasoning for this one. They mentioned that why they choose carbon. Why don't they choose anything else? Actually, in the beginning, right, like when they start to find the mass of atom, they use hydrogen. Because hydrogen is bond with just 1 only. So that means if you use 10 hydrogen, the mass will be 10. But then hydrogen is a gas. It's very hard for you to handle. How can you find like the hydrogen and then you put it on the other side? Cannot, it is a gas. So they choose carbon. Why they choose carbon? Sometimes they do ask you in the structure, why we use carbon? Because carbon is a solid. It is easier to handle. It's easier to use a solid to compare the other person's mass. Okay, can and it is very easy to obtain because carbon is actually charcoal. You can find it everywhere, carbon. But hydrogen, very hard. In air, it has a lot of gas inside, oxygen, carbon dioxide, everything. So if you just want to extract the hydrogen out, it's hard. That's why they choose carbon 12. One of the easiest reasons is because it is a solid. easier to handle and easier to obtain. In that case, I can use ferrum, then multiply 1 times 56. 只剩 carbon, getting a charcoal and getting an iron. Iron is a lot harder, bro. Iron, imagine last time you want to dig to the bottom of the earth and then to get the underground and then to get the ores, and then you have to go through extraction of metal again. It's not easy. Understand or not? There's a reason why they use carbon 12. Okay? Getting a charcoal and getting the iron, charcoal is a lot easier. Okay, then you got 28 already. So it's 28 times heavier. No unit. Relative got no unit. Now they want you to find molecular formula. How to find molecular formula? CH2 times N equals to 28. Then when write molegram is not comparing to the carbon. That is the result after comparing to carbon already, they use it. It is like just now, I said my mass is 3 times heavier than Junghao, right? Because I use 3 pieces of Junghao. So relatively, I'm 3 times heavier than he. But from the experiment, I also know that I'm actually 3 kg. So I can use it as mass as well. That means they are the same thing. 3 pieces is equally to 3 kg. Sometimes that means when they write the word relative, you don't put the unit. No relative, then you put the unit. Just like that. Okay. So this one, 12 times 1 times 2 times n equals to 28. N is equals to 2. So CH2 times 2, we get C2H4. Yep, that's the answer. C2H4. Okay. Lastly, this is a question whereby they want you to find answer from the back. We also done it in the class before. X gram of iron, 5.04 gram of oxygen. To form an oxide with the empirical formula Fe2O3. So they told you that the empirical formula is Fe2O3. That means the final ratio is 2 to 3. They want you to find this mass. How to find the mass? We do it like what we have been doing for the previous question. We use the mass to divide the molar mass. You see, given here, 56. By the way, the value you have to calculate yourself are the 0.21. No value is given here in exam. 5.04 divide 16, the molar mass of O, to get 0.315. Okay, 0.315. Here comes the problem. In order to find X, I need a value here. How do I find the value here? We use ratio. You see the ratio of Fe to O is 2 to 3, right? If the new value is 0.315 for O, then what will be the value for Fe here? According to ratio 2 to 3, something to 0.315. How to find this value? Yes, correct. Like mathematics, you put 2 lines and then you start dividing. 3 divide 0.315, you get 9.524. In order to find the n, You move it to the other side. This one come down. You get 0.21. 0.21. Don't do times, it's divide, not times. Wait. I thought mathematics, you move thing like that is divide, not times. So you get 0.21. So 0.21 is here. So in order to find the x, you move 56 to the other side. That means 56 times 0.21 to get 11.76 gram. Yeah, like that. Can So basically, after we have go through like so many questions, 1, 2, 3, 4, 5, 6, 7 calculation questions already. Every time when you do your own revision, for those like who want to like improve, you have high target, you want to get A or something like that in your SPM or full A plus. Here is a very good habit which you can do, which is every time when you finish a revision, there must be something that you do know how to do, and there must be something that you like. When you are doing the question, you'll be like, oh, it's like that one. For this kind of for this kind of thing, I would purposely write it down in a paper or a notebook. For example, this is your chapter 3. Form 4 chapter 3. What am I doing? I will write down the important things that the mistake that I made just now. For example, there is a difference in mass, molar mass, relative mass in terms of their unit. So I can always write down to remind yourself. You don't have to write a very pretty notes, a very nice notes. You just put in everything that you do know. Mass is gram, molar mass is gram per mole. But when you ask relative, no unit. To remind yourself, next time when you before your exam, you just open back this book, you read, then you know, oh yeah, these are the things that I do know. Maybe just now, the atoms, when the question want to calculate number of atoms, I have to be very careful. Be careful. Why be careful? Because if the substance given is molecule, for example, simply write something wrong. C2H4. I have to multiply 6 to get atoms. So extra steps. If it is already atom, then straight away atom. So I will write down all these kind of important things, which I don't know, the mistake that I made. It will be easier for you to study. If you don't do this, next time when you go through these questions, you will see, wow, everything seems very perfect. It's like, oh, I know how to do this. Oh, okay, can, okay lah, that's what I can do. So it's better to mark it with red pen or something. Just now that question, can you go through again? Which one? Which question? Which one? This one. This one. Which question you want me to go through? Okay. Now we will go to chapter 2. Later. This one later. Let me finish teaching like what I have to do today first. Later I explain again to you. So here, in page number 4, we want to go through a little bit about chapter 2. Yeah, the slightly easier chapter, very similar to your form 1. In page number 4, see, do you know the name of this format? Atom, we can present the information of an atom in this form. What do we call this format? Very good, Jacinta. Standard representation. So exam can ask you to write the standard representation out. Make sure you know what is that. So why do we put things into this form? Because it gives us all the information of an atom. What are the things that can be found in atom? What are the information can be found in atom? Atom is made up of proton, electron, and neutron. Proton, electron, and neutron, they are known as subatomic particles. So when you see subatom, it actually means proton, electron, neutron. Okay, this is what you learn in form 1, right? Form 1 or form 2, I can't remember already, but something that you have learned before, proton, electron, neutron. So let's say I give you an example. Before giving you the example, I tell you first, the number on the top represent nucleon. What is nucleon? Nucleon, this word looks like nucleus, right? Inside the nucleus of an atom, you see, in the nucleus is where we can find the proton and neutron. Not just neutron, proton and neutron. Only electron is in the shell. This is like the solar system. The sun is here. Inside the sun, the nucleus, we have proton and neutron. And then the number below is proton. Okay. So let's say, I have an example here, A. Example A comes with 12 neutron and 11 electron. Can you please tell me there are how many proton in this element A? Yes, very good. Electron, because electron is the same as proton. Electron is equals to proton. So it's also 11, very good. So when I have to present this thing in the format form, I'm going to write it as A. The number on the top should be, yes, 23 on top, and then 11 at the bottom, like that. And one thing. Okay, students starts leaving the class already. Hi, okay. Yeah. Remember, nucleon, something very important here. You might not know, or you forgot about it already. Nucleon number is actually the same as relative atomic mass. It is the mass of the alphabet. Okay. Nuclear number is the mass. So sometimes they can give you nucleon and they want you to know that it is the relative atomic mass. So you don't ask the teacher, hey, why this paper doesn't give a relative atomic mass? Because nuclear number is the same. Okay, then one more thing, electron arrangement. You all know how to do electron arrangement or not? Yes, okay. That means with the given amount of electron, you have to put them into the shell with a very simple rules. The rules is if the smaller shell, the one that is closest to the nucleus, the first shell can fit up to 2 electrons maximum, because it's the smaller shell. And then all the rest of the shell, second and third, can fit up to 8 electrons. That's the rules. So that means when I have 11 proton, 11 electron, what I do, 11 electron, now imagine, I put 2 into the first shell, full already. Then I open the second shell and I put 8 log, maximum 8. So 2 plus 8 is 10 already. So I need to open another shell and put 1. 2, 8, 1. That is the electron arrangement. Simple. Can good. Let's do some questions. Let's try some questions. The questions is in page 15. If the electron exceed 20, 2, 8, 8, 2, if it's 20. 2, 8, 8, 2. 20 is the maximum they can ask you already. They can't ask you more than 20. Because after 20, some of the shell can fit up to 18 electrons. That one is when you learn it. You will learn that thing 18 electron when you further study in your foundation or pre-U next time. And now maximum is 2 and 8 only. According to this atom W, they ask you the meaning of isotope high. What is the meaning of isotope? Atoms of the same element with same proton number but different
number of neutrons.
Yes, different number of different nuclear number. Thanks for your answer. Okay, different nuclear number. There is another way of writing this definition. By the way, I will go through this thing in the class this week. Don't worry, for those who can't catch up. If you want to change the word proton number to number of proton, can or not? Can. But you have to make sure it is followed by number of neutron. That means they have to be used in a pair like this. Number of proton, number of neutron. Proton number, nucleon number. Cannot mix and match like the McDonald's. Number of proton, nucleon number, 0 mark. Okay. Subatomic particle W. Subatomic particle is PEN, proton, electron, neutron. They ask you the red color one. Red color one is in the nucleus. Is in the nucleus. In the nucleus, we have proton and neutron. So this is proton or neutron. Proton or neutron? Why is it proton? Cannot be neutron, man. Neutron is also inside the nucleus, man. Yes, because same with electron, correct. You see, 6 electron. This one also 6. So it will be proton. This one is 1, 2, 3, 4, 5, 6, 7. Different number is neutron. So the mass of a proton is 1. The charge of a proton is +1. Nucleon number, just now we said 6 plus 7. So equals to 13. Easy. What is this? A salted fish or a fossil? Okay. The fossil can be estimated using Q is an isotope for carbon. State the name of carbon of atom Q. Which isotope can be used to estimate the age of fossil? Very good. Carbon 14. For those who do know, never mind. This week, maybe we'll do this in the class this week. What I want to do is actually this question. In first term exam, it's like a confirm come out question, unless your teacher very lazy. Okay. Carbon has two known isotopes. What is the meaning of isotope? Isotope is like family member, siblings. They come from the same family. Human, right? If I suspect that Ashton is my brother, what can I do? We can do DNA test to know whether we come from the same family or not. But for atoms, right, how do they know they are from the same family? Proton, because isotope has same proton. Proton is like their DNA. See, it tells you that carbon has two members in the family, 12 and 13. The relative abundance of C12-6 is 99%. Carbon 13 is 1%. Calculate the atomic mass. When you see isotope, some percentage, what abundance, percentage, and then want you to find relative atomic mass. Remember, this is a very simple question, whereby they just want you to find the average mass. The way of solving this question is find the average. What is the meaning of average? You see, just like I told you all, right? Nucleon is also equals to the atomic mass. So they're telling you that there is 99% of carbon 12. So what I do? So 99 times 12. So 99% of them, imagine it has 100 atoms. 99 atoms has a mass of 12. And then 1% is 13. Plus all the mass together. 1 times 13. I will be able to get the total mass, right? Divide by total how many atoms? 100%, 100 atoms. So you will be getting the average mass. (12.01), which is 12 law. So you go back to the same thing. Atomic mass of carbon is 12. Okay. Can after this, we do one more question, then done. Two different physical properties between carbon 12 and carbon 13. What is the difference between 12 and 13? Atomic mass. Atomic mass. And then different number of neutrons. Yes, they have different number of neutrons, correct? They have different density. These are the things that you can write. Density, number of neutron, number of nuclei, atomic mass. Or you can say melting and boiling point. These are the physical properties. Two isotopes of carbon react the same way. If you see questions saying react the same way or same chemical properties, you have to know that, okay, in the same family isotope, they do react with the same way? The answer is yes. They will react the same way. They have the same chemical properties. Why? Because they have the same proton number and what must mention these are same number of valence electron. Valence electron means the last number. What to do with this last number? Why we have to mention the last number? Because last number is the one that decides the chemical properties. I will be doing this in class this week. So I will just go through quickly. If you can't understand, never mind, I will explain in class again. This is for those who have learned it already and you are good with it. Then I will just answer. I will just explain it quickly. Chemical properties is, example, let's say A has an electron arrangement of 281. This is the electron arrangement of an atom. But then question can ask you electron arrangement of ion. Electron arrangement of ion. What is the meaning of ion? Have anyone done this kind of question before? And you know the difference between atom and ion? Ion has charge, right? Do you know why atom has charge? Okay, see, atom can turn into an ion when they achieve very good, sorry, when they achieve stable electron arrangement. What is the meaning of stable electron arrangement? You see, this atom is having 3 shells, 2 electron, 8 electron, 1 electron. This is not perfect, right? It is not full. Some of the shell it has a lot of empty space. So let's say I'm very OCD and I see this, I'm not happy with it. I do want my atom to be like 2, 8, and 1. I want the shell to be full with electron. I don't want to see any empty space in the shell. So what can I do? We can choose to plus. I write properly, okay? We can choose to donate or receive electron to make it perfect, to make the shell fully occupied by electron. Donate means minus. So you see, I can choose to minus the electron off. I just throw it away. Then it becomes perfect, 2 and 8, full. There's no empty space. I can choose to receive electron. Receive is plus 7. Minus 1 and putting 7 electron into the shell, which one is easier? Which one requires lesser steps? Minus 1, right? Then we will go for this method. Donate the 1 electron and make it 2, 8. So the electron arrangement of the ion will be 2, 8. I throw the 1 electron away to make it looks perfect. But when I do this, right, imagine I throw away the negative charge. If a person, you give away all your negative thoughts, you throw away all your negativity, you will become a very positive person, right? So same thing. When this A throw away, donate 1 electron away, it becomes a positive 1 charge. So this is where does the charge come from? Understand? Because 1 electron lesser, you see, in the first place, it has 11 proton. 11 electron. That's why no charge. Atom is neutral because they got same number of proton and electron. After minus one electron off, they no longer become equal. It has more proton than the electron now. One more charge positive. Okay, can teacher, why not plus one electron achieve duplet? Do you know that duplet is meaning is for the first shell only. Only the first shell can achieve duplet. The rest has to be octet. That means 2 is not maximum for the other shell. Only first shell can duplet. Now, students, I ask you last question. If this is B is 3517. What is the electron arrangement of this atom? What's the electron arrangement of this atom? Yeah, Isabel, very good. Yes, 287, good. 17 proton, 17 electron, so 287. If question asks you, hey, what is the electron arrangement of ion B? What would be your answer? Try to make this perfect. Yes, it's going to be 288. We can choose to plus or minus. You see, if I minus, I go to -7. If I plus, I just have to add another 1. So I will choose +1. When the substance receives one negative electron, receive one negative news, -1. If receive two negative, receive 3 negative. Understand? Can just like that. So please be very careful with atom and ion in your first term exam. What if it is 4? We do add or remove. Yes, very good. I always get this question. Don't worry, they are not going to ask you 4 because 4 is what you will be learning in chapter 5. Until then, they will never ask you 4. Okay, guys, this is chapter 5. They will never ask you 4. Okay, they will only ask you 1. Okay, 2.1, 2.2, 2.3. Last number 1, 2, 3. This one with -1, -2, -3. They can ask you 2, 8, 6, 7, and 5. This one will be +3, +2, +1. Like this only. -1, 2, 3 or +1, 2, 3. This is all they can ask you. Okay, if there's no question, then yeah, that's all for this class. And yeah, bye-bye. Bye-bye, bye-bye, bye-bye. Thank you, everyone. Bye-bye. Bye-bye, see you. Bye-bye. So if you donate, then positive. Yes, if you throw away electron, then it will be positive. Which shell can receive more than 8? Usually the third shell can start to have 18. But that one is next time now when you start study in college or uni. The third one. Bye, Mickey. Bye-bye. Bye, everyone. Wait, Malcolm, eh? Okay, thank you, everyone. Bye-bye. See you. Bye, Ethan. Bye. Bye.